Hello, it's Duncan. Software development is split between static and dynamic typing. In a static language like Kotlin, we can rely on the properties and operations applicable to a variable given its type. This is usually brilliant, but when we're dealing with data, it only works if we both know and specify the structure of that data. That can be time-consuming if it's possible at all. In contrast, data-oriented programming represents data as lists, maps, and primitives, and provides tools to introspect and process these structures. This saves the overhead of specifying the types we expect to see, but we don't get convenient methods and properties to interact with the objects. There is a middle ground though. We can start from generic data types, use extension properties to capture the structure that we find, and then gradually add data classes where appropriate. This is a powerful technique for dealing with structured data in a type-safe way without upfront cost. So let's find out how we can use Kotlin to do data-oriented programming with gradual typing. Alison, the owner of Gilded Rose, is an astute businesswoman. She knows that she really needs to keep an eye on the competition, and she can do that with Google Maps. Now what she's asked us to do is find highly rated magical goods stores, summarize some data about them, and tell us their location. Now it's not clear why she wants the location, maybe call it an airstrike or an old-fashioned curse, but we're choosing not to ask that question at the moment, because data is just data, right? So in order to keep our jobs, we've signed up with our Google account to have access to the Maps API, well actually the Places API, which gives us data about places. And we found this endpoint, this text search, that allows us to take a text representation of the sort of thing we're looking for. And we post to this particular endpoint with an API key and a string, and we get back some JSON. And that JSON is a place object. So let's have a look at that. Here's the sort of schema for a place. It has a name, an ID, a display name, and lots of properties that themselves have a type. So address component, for example, has a long text, a short text, types, and so on. So it's potentially quite a deep structure. Let's have a look at what we actually get back. Now I've made a start before you arrived. I started on this competition tests, and there's this fetch data that makes a request that's equivalent to the curl that we saw in the web page. And we write that to a data file. And if we look inside that data file, and it's here, you'll see that we have a places, which is an array. We default it away, that's the top level. And then the individual places, oh yes, here you see we've got the name and the types and address components and all sorts of stuff. Now then, our hand-rolled JSON parser isn't quite ready for production yet, and we've been using Jackson in the rest of this project. And we know that we can parse JSON by creating an object mapper and asking the object mapper to read the JSON as a tree. And if we print that out, let's run this test, then we get something that looks, in fact, very much like the places response, white space aside. Now then, what is the type of this? Well, it is JSONNode. And JSONNode is Jackson's representation of a piece of JSON tree. And it has various methods on it to ask it what type it is, whether it's an object or an array or sort of primitive. If it's an object, then to ask for the values of its properties and so on. So looking at our response, we know that the top level is an object. So I think we should be able to say expect that JSON is a object node. See whether that's true. It is good. Now inside here we can ask questions about that object node. So we can say, for example, that getting, I need to add and. Now we can say get, what about an object node? Well, I think we can ask for get property. And at this point you can see I'm fighting with Jackson's API. I need to know about Jackson's JSON nodes, I need to know about its array nodes, I need to know about its object nodes and so on. So instead of starting with JSONNode, I'd like to use the maps and lists and so on that our own JSON parser returns. And in fact, Jackson can do that for us. So what I think we can do is to say that we want to read as a map of string to any. But instead of read tree that returns JSON nodes, we want read value. Import that. And now the issue here is that our return type is our map of string to any. Good. So now, arguably, our result isn't JSON, it's just data. This is data-oriented programming after all. And we can expect that data, well, it's not going to be an object node. So now we're just dealing with the map. I know the interface to map. So we can say things like get, which is the map index operator. So get places is and that's an array over on the right-hand side here. So that will map to a list, I suspect. Let's say that. So is a list of some type. Try that. That's true. And now we have matches on list. So we can say has size. Now I don't know how many results we have got. So let's put in a number and see what the actual number is. So there we are, we've got a failure and has size 100. We found 18 things apparently. So let's make that 18. Good. So by asking Jackson to populate a map rather than its own JSON node, we've gone from a result where we have to look up all the operations to one that we're very familiar with because we're always using maps and lists and so on in Kotlin. An alternative, of course, would be to define data classes to represent the structure that we find inside our JSON. So we could have a place type with a name and an ID and types as an array, and address components. Well, each one of these would be another type of address component, I suppose. But here on the right-hand side are all those types that we'd have to generate in order to parse this. That's an awful lot of work if we want to cherry pick individual bits out. So we don't want to do that. We want to work in terms of maps. But we'd also like it if we had some sort of type safety on top of those maps. We'll live without that for now, though. Let's just see how we get on analysing this data with maps. So this is our data. We can say that places is our data at places. And we know that's a list. And the type of that list, well, each one of these things is itself a JSON object. So we're representing JSON object as map of string to any. So let's put that in there. And I think maybe we could provide ourselves with a type alias of JSON object is map of string to any. And now we can say that our data is a JSON object and our places is a list of JSON objects. And if we're right, then we should be able to say places dot for each one of the things inside here is going to be an object. Let's see whether we can get the name of the place. Now it's not that thing because that's just some sort of URI. And we'll go down and look for, here we are, display name. But that itself has some structure. So we'll go down and we'll say this JSON object, we'll say val display name is our JSON object. And we know that's going to be the thing called display name. And that's going to be as, well, this is itself a JSON object. So we'll say JSON object. And then val text is display name at text. And that is a string. And let's print that text. And I think we can take this away and run. So there we are. Now we have the International Magic Shop, the Geek Retreat Ipswich, and so on and so on. Good. Now this casting is going to get old quite quickly, but what we can do is we can say, what if we had a function that took JSON object as its receiver and got a required, which means it has to be there, field. And it would take the key, which we know is a string. So this at simplest would be get key, but we want something to do the type for us. So if we said this function takes some sort of t, then we'd like to be able to cast to that t. But now this is telling us that would be an unchecked cast. Is there any way we can make it a checked cast? And the answer is yes. If we make this an inline function and say this is reified t, then the compiler will pass the actual type that's required into here and it will become a checked cast. And so now we can say data required places. And we can do the same thing here. So this is JSON object required display name. And this is display name required text. Now, so far that hasn't helped much, but when the compiler knows the type, it will pass it in. So for example, if we say now that this is explicitly a map of string to any, which we know to be JSON object, now we can remove the cast and the compiler will say, well, look, you're assigning to something that's a list of JSON object. So I'm going to pass that in as this verified t and make this cast safe. We can do the same thing here. We can say display name is a JSON object, and we don't need to do the cast. And we can do it slightly differently for text. We can put the type in here. So we say we want a required string. And you see again, the cast is not required. Is that all true? It turns out that it is. Worth noting, by the way, that this object mapper read value is itself an inline function, which means that as we've said this is a JSON object here, I think we should be able to take this out of here. And indeed we can, which is nice. Now then, what happens if our map doesn't have the particular value? So if we say this is no such and run that, well, we get a null pointer exception. Null cannot be cast to collection. Why is that? Well, that's because this thing here has returned null. Interestingly, we can sort of solve that problem by making this a JSON object question mark, and then asserting that that's not null there. In fact, it will be, we know that. We'll see that we've moved this to a null pointer exception here, so we didn't get a class cast exception here. I suspect we should disallow that by saying that our t should extend any in here. That sort of solves the problem. You see here it's saying places is always a non-null type, but the problem is we can always take a non-null thing, which this will always now return, and assign it to a nullable thing. Anyway, this will get us back onto something of an even keel, which is to say we get our class cast back. I think we'll deal with that case explicitly by saying convert to a block body, take this thing as a value, which we know may be null, and then say if value is null, that's an error with cannot find key. And Kotlin rightly tells us that we could use an Elvis in there. So if we do that now, we get a better error message. So let's return this to places and run. That's good. Now what about if we had the wrong type? So we say that this text is in fact an integer. Run that. Now we get a class cast exception, which is right but not very helpful. So I think we could probably say here as question mark and then put in an Elvis to say error value for key is not a, and I think we can get hold of t class. Try that. And now our error is value for key text is not a Kotlin int, which I think is true. Good. Note that we're not really doing TDD here. We're exploring whether or not this approach has legs. If we'd use JSON object required in production, then I think probably we'd want better tests around it. Okay, back to this being a string. Good. At the moment here, we're having to get a JSON object in order to drill down into it. We're not really interested in this thing. We're only interested in the text inside it. I think we'll find that's a common case. So what I propose to do is to move this into a variable of key 0. This will make key 1. Move that out of here, and then if we take this thing and make a method out of it, this will also be required, but it takes 2 keys. Now we'll take that out of here, up into the top level. We'll make our JSON object the receiver, and we don't just want to work with strings, so we'll do the same thing as we did in here of saying this is going to be an inline fun of a reified t, which we know can't be null. It will return a t. That will be our t, and we can inline that, and we can inline that. But in order to do that, then we have to say that this is going to be a JSON object. And in here now we need to say that the type of the text we want is string. Inline that again, and inline that. And run. There we go. Now once we've done 2 keys, we could of course do 3 or 4 or 5 and so on. If you're really clever, you can use var args in here, write a recursive implementation discover that you can't call inline functions recursively and fall back on a fold, but I'll leave that as an exercise for the viewer. Now, one of the things that Alison is interested in is the country of each store. So we've got the display name. Let's work out how we find the country. We'll have a look in the data. We've got opening hours. Here we go. We've got United Kingdom or GB, and that is part of address components. So it turns out that in order to find the country, we have to find the address component whose type is country and then find the text from that. So let's have a look at that to remind ourselves while we're here that this is our place. And I think we might inline that. Okay, now address components within a place is place required. This is going to be a list, and each one of these things is itself going to be a JSON object. And we need to tell it where to find it, and the answer is under address components. Let's just print those for now and run. Okay, well that's working, good. Now we need then to find, so we'll say address components find. This is itself a JSON object, which we'll call component. Now then, let's look down, and again, we need to find the types. So we'll say val types is component required. This is itself going to be an array of strings, so that's list of string in Kotlin. And the name is types. We need to find the type contains country, and this will be country component. That itself will be a JSONNode, and we want to print the country component short text. So that's required short text. But as we may not find one, let's allow that to be null. Let's see what we get, shall we? And here we had the International Magic Shop in Great Britain, the magicshop.nl in the Netherlands, and so on. Magic King Cannabis Store in Belgium. It's all looking good. Now this is all nice and flexible, but it's not very readable. Can we do better? And I think the answer is yes. Starting with these required functions, we can make extension properties. So if we were to take this thing here and extract a function, and we're going to call this display name. And now we'll take this and make it the receiver. Move it up to the top level and convert it to a property. And I think display name will do, so we can call that just display name. We can do the same thing with this one. We'll take that, make a method, which is address components. I don't know how to make IntelliJ except the thing that I've actually typed anymore. Make this into the receiver, move it up to the top level, make it into a property, and that now gets a good name. Run to check everything is still good, and it is. And now we've got a couple left, which are this one here, so we can do that. That's our receiver, and this is now a property. And this one, any is a strange name, but we'll fix things up. This wants to be our receiver. It doesn't want to be nullable. We want to make it into a property named short text. And we really want that to be a string. And we need to fix this up here with a question mark dot. And now we have some nice simple types. We can probably say here that we want place dot display name plus that. Convert that to a template, put in the space, and get rid of that. Inline that, and run. Good. Okay then, I think that may be a good point to check in with fetch name and country from Google Places results. Good. Now there's one major problem with this approach, and that is, unsurprisingly, type safety. So for example, we have display name on place and short text on country component, but these aren't actually tied to anything other than JSON object. So I could write display name on here, and if I did and ran, then we would end up trying to extract from a map that didn't have the right key in it. Can we fix that? Before we do, I should say it's not quite as bad as you might think, because the return types have to line up. So here we've got data required places. We might think that we could do data.shortText, but that doesn't compile because we require a list of JSON object here rather than string. This won't always save you, especially if you don't declare the type of your variables, but things aren't as bad as you might think. Anyway, returning to here and just checking that we run okay, and we do. I think maybe JSON object is a bit of a specific name. I'm going to rename this now to PropertySet. That wouldn't have any effect, but I'm just going to move this thing as a type alias up into here. So we can see that down here we have the general component of data-oriented programming, and here we have properties that are specific to our particular domain. What I propose to do is say, there's this place. What if we were to create a class to represent that? So we might say the data class, and it is place. Now, instead of putting the individual properties we want in here, we're going to put our property set. So I'm going to call this, I don't know what, properties, which is a property set. Now, once we've got a property set for place, we could convert it into this data class for place. I think maybe we'll do that in here. So we'll say this place is map, and we can use the place constructor in here as a reference. And if we do that, then the type of this thing will be place. Unfortunately, we've lost access to address components. Now we could move them all in one go, but in fact we can gradually get there by saying that place is a property set by the properties inside it. And if we run that, all is still good. And now we have place to hang our display name on. So we can make display name not take a property set, but take the actual place. That would mean that we couldn't, for example, take this one here and say this was display name, because that now won't compile. So this is the same and allows us to migrate. And now we can take this thing and move it up as a property of our place. And our code still compiles and runs. And now we can hang other things off of this place. So for example, address components are only a property of place, and we can decide to leave them as extensions, or we can move them as actual properties. So gradually migrating. And now we can see that the client code probably doesn't really want to be involved in this find operation here. So if we were to take this thing out as a value there, we could take this code as a method called helpfully s. Now we can take the place and make it the receiver. This is going to be country code, and we can inline that. Take all this out of here into there. Make that public. And now our clients may not care about address components, so we can hide those inside here. Still good. And in turn, in fact, we can hide these inside here as well. At the point where we want to reuse address component, well, we do the same thing. We say we want a data class address component, which has some properties, which are a property set, and is itself a property set by properties. Now we can make our address components a list of this type by mapping to address component. Note that everything still runs at this point. Now we can make these extensions on the address component and pull them out of here like that. And now we can tidy up a bit. We can inline that and that. And this is an expression body, and run. Splendid. Oh, and it looks like I failed to make country code into a property. And one final thing we can do now we actually have a type is to eagerly evaluate things like display name and country code. So at the moment, if our place property set doesn't have a property of display name, which in turn has a property of text, then we'll only fail when we call this. But we can convert this to an initializer, and we'll discover as soon as we try and construct our place. And we can do the same thing here, and here, and here. And the effect of this is to check that the input JSON has all the properties we need, but none of the properties we don't need, as early as possible. One last little tidy up, I think, if we made that it would fit on one line. Good. Well, I hope this episode has shown how we can start with very general data, just maps, lists and primitives, use those to extract just the data we're interested in from more complex data, and then gradually add information about the types and the structure so that our calling code can work in terms of strong types rather than dynamic types. I find this a very powerful approach for dealing with structured data in an initially ad hoc but later more formal way. And as you can see from the right hand side, very little code is required to get you started. It's more of a mindset than anything. In the next episode, I think we may look at a property set optional, how that would work, and maybe how we can go about building structures in a data-oriented way. If you'd like to see that, then please subscribe to the channel, like this video so other people find it, and then if you haven't already, create a Christmas wish list with the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.